Hello, welcome! This is a Lingo 2 mapmaking tutorial, and in Godot 4.3 steamworks. And today I'm going to be showing you through the different listeners. I'm going to be doing this in rather rapid order, just kind of giving you a brief overview of each of them. And if you want a better explanation of any of them, let me know. I'll make another tutorial for it. So first up, I have just put listen into the bar here and I've just instanced all of these nodes that were in here, and I've also taken the two scripts that I made and put them on two nodes here so we can explore them. So, achievement listener. You might be thinking this is related to the title cards that will come at Lingo 1, such as the bearer or the bold when you fill in a countdown panel. That's not what this is for. If we read this through, this is for unlocking the Steam achievement. So this is something you will not be using as a custom map maker. Animation listener. So animation listener, when this is triggered, I should go over that briefly. As you may remember from the receivers video, the first tutorial that I made, you need to put the senders or sender groups into the receiver thing here, the receiver dock here, and when those complete, look at the receivers tutorial to know what that means, the listeners will trigger. So the animation listener will basically apply the same animation as you would find on a door. It will tween between 0, 0, 0, 0, 0, 0 for all of these values, and -5 or -10 or whatever. If you hit remove on complete, then when the door or whatever is finished lowering or opening, it will also disappear and it won't come back. So let's take a closer look at animation listener to see exactly what it does. So it runs its animate function, and it puts its animate back at that, and it just creates a tween. It gets the hinge of the parent. This is why I wanted to look into this and kind of see. So right now, if I would put animation listener under this block, it will not animate this block. What it will do is it will look for a node called hinge below the block, and then it will move hinge. So if we just look at a door real quick, you'll kind of see why it's made like that. If I look into the subscene of a door, you can see that I have the main door, I have the hinge on which everything is built, and then I have everything beneath that. The reason why there is an extra node there is so that the main door can be rotated, and hinge, which is going to be rotated back to 0, 0, 0, isn't going to reset its transformation when we rotate it. So the way that tweening is done, let's say I move hinge and I move it off in the distance there. I'm actually moving hinge, not door at this point. And I want the door just to go downwards and open. Right now what will happen is that it will suddenly decide to jump over back to origin and then also sink 5 feet while it's at it. So I'll take that diagonal path, because it's going to 0, -5, 0. So by making another node called hinge under the door, we get to use the local dimension of door. So I can place the entire thing door as I want, and now hinge is going to sink to -5. If we look at its transformation, now it has -5. It is below the floor that is defined by door. Let's just undo that. I don't need to change my thing permanently. Alright, okay, yes. I have made a rather large door here, which is why that looks so disconcerting. So that is animation listener. Environment listener is going to take two environments as input. So let's just do a quick load and see what our environments are. We can see the different kind of environments we have, and it's going to set those. So I'm going to go up to the world environment here, and instead of default, let's figure out what solar is. If we look at solar, the sky has darkened slightly, and we have a different color gradient on. If we let's look at something underground. I know underground is exciting. Now we have no sky. We just have blackness stretching out into the dimensions. This is what's used in places such as the underground maze. I forget what that's called anymore. My goodness, it's been a while since I played Lingo 2 myself. It's used in the areas where you're not supposed to ever see the sky, and there's not supposed to be that much ambient light. It also has volumetric fog. So as I go further and further away from that, it's going to keep getting darker. But it doesn't have... Actually, underground might not have under... No, it does have volumetric fog, it's just very low. Whereas if I go to... What's the one used in the graveyard? Is that lunar that's used in the grave? Nope. I guess lunar is used for nighttime. Maybe it is the underground that's used in the graveyard, and it's just when you wander away from enough stuff, it'll become invisible, but only in-game. I don't exactly know how the environmental shaders work in Godot 4 yet. I haven't really looked into it. So, environmentListener. When you enter into it, when it triggers, it will put on this one. When it unsolves, it'll put on this one. GravityListener. This is going to change your gravity so that your up is this direction. This is going to be a vector, so right now it's pointing at 0, 1, 0. It's going to be pointing in the y direction. If we want your direction to be, your gravity to be on the wall, we would make 0, 1, 0. If we want it to be, going upwards diagonal, we would put this to about 0.717, 0.717. That was not what I wanted to put there. The reason is that this is going to be normalized, and that's going to come out to, the entire vector now has a length of 1. If I take the square of these numbers, the square root of 2 over 2, and I add them together, so square root of 2 over 2 squared is going to be 2 over 4, or 1/2. So if I add 1/2 plus 1/2, I get 1. If I take the square root of that, I get 1. That is the length. That's Pythagorean theorem. However, you don't actually need to normalize. The very first thing I do is orthonormalize the bases that you send me. So once this is orthonormalized, you don't need to care. You could just put 1, 1 if that's easier for you. But I'm always going to put in that quick vector math lesson because it's going to come up on a lot of custom map making. So GravityListener, it flips your gravity when you solve it. The keyHolderListener is going to pay attention to a key holder, and then it's going to look for the particular key that you put in, whether that's E or F or whatever. So if I look at, say, the L key in the partial, I think that's what it is, opening up the entrance back to the control center, there is a keyHolderListener, this is going to be looking for this, here we go. This wants its holder to be sender 0. So the first entry in here is going to be the key holder that it wants to look at, okay? It's not a panel, it's going to be looking at the key holder. And if it's not looking at a key holder, it's going to crash because it's going to try to get the holder's held key. Only key holders have that variable. And if the key holder has that key, so if it has an L, it will send a signal. If it doesn't have an L, it won't send a signal. The keyHolderResetterListener. I haven't looked at this one before. Let's figure out what it does. So it plays a pickup, it unlocks all key holders. This is what is used in the key resetter in the entry. So basically when you enter in this, it's going to unlock all of your key holders and return them an entry. I don't know exactly, I should look about how unlocks works, because let's look further into that. And that was going to be unlock all key holders. So this returns visit key holders. Something true. So let's go to visit key holders. Key is equal to anything. Remove key is equal to false. Unlock key is equal to false. So this is going to look at your map, at your universe. I don't know how well multi-maps are implemented yet. I don't know how well universes are implemented yet. I have yet to look into that. I don't believe they are from what I've seen so far. It's going to look at the key holder save, and it's going to basically reset all of them. Interesting. There's a nice little thing here for the congruent where it skips C1 and G1 because those are the ones that you put in that get permanently gotten rid of. So those are going to permanently be in those key holders. Interesting. Wouldn't have done it that way, Brenton, but hey, it works for you and it worked in the game. So it's going to modify the keyholders.save. It's going to give back all your key holders. So this should work on your custom maps as well. keyUnlockReaderListener. I have no idea what this does. The ready function calls a readier function. Ah. So what this does is if you have a key of the appropriate level, it will trigger. So if I load into a map and I have H2, that's what I have it set to right now, then this will trigger. This will send and trigger to something. So this is itself a sender. So this is probably not how we implemented personal scenes, but if you wanted to implement personal scenes, you could do it this way. keyHolderReaderListener is probably how all the cyan doors are unlocked. I haven't actually looked into that yet. I covered merging listener in the receivers tutorial. Brain damage is getting worse today. And what this does is it takes in a number of senders, and it just sends a signal when it completes. So the example I gave in the receiver tutorial is, what if I have 3 different rooms that have 5 panels each, and I want you to have to complete 3 panels from each room. I could just collect all 15 panels and say complete at 9, but then you can complete 5 panels from one room, 4 panels from the second room, and none from the third room. With merging listener, I could have 3 merging listeners, which I'll go, I'm going to send a signal when I'm complete at 3, and these are each connected up to the 5 panels from their respective rooms. Then they would only be complete when at least 3 panels in room 1, at least 3 in room 2, at least 3 in room 3 are completed, and then send their completion messages either to another merging listener or to the sender directly and tell the sender to trigger at 3. So the merging listener just it merges different senders together. The one-shot listener, this will trigger once and then not at all. So if I want something to happen only once, I would send all the signals to the one-shot listener. The one-shot listener would send its signal to whatever it is I want to trigger. And then the one-shot listener, it's actually it doesn't have any untriggered behavior. So once you untrigger the stuff that triggered the one-shot listener, nothing happens. It just stays triggered, and that's what the one-shot listener is for. The ordered listener. Let's look through the code here, because this is going to be important to understand what's happening. So now it's going to go through all of my senders in order, and it's going to look at all the ones that are complete. So it's looking for panels in particular. Anything that does not have the isComplete variable is going to crash here. And for everyone that is complete is going to be Boolean. So this is just going to say, if isComplete is true, is what this is saying, current item plus equals 1, and triggered plus equals 1. And if your current item is equal to all senders.size, emit signal trigger. But it's also going to set current item to 0 if it hits something that is not the current item. Okay, let's go through that, and let's think that through. This is going to be a bit difficult to really detail. I imagine the difficulty in coding it is what Brenton made it code it in such a weird manner. So say I have 8 panels. When I solve the first panel, this is going to look at the first panel, it's going to check if it's now complete, and then it's going to increase the current item count. If I then complete the third panel, it's going to look at the second panel. And if the second panel is not complete, it's going to set the current item to 0. And then the current item is never going to equal the allSenders.size, as long as I, don't reset everything back to 0, because the current item will have started from 0. I might get it up to 6 with the other 6 panels, but it's never going to go upwards. And when I untrigger anything, the current item drops back down to 0. So if I solve panel 1, 3, 5, and then I unsolve 3, the current item count is now back at 0. Even, if I had triggered 1, 3, 5 in the correct order. So there are a few difficulties with this. It won't work exactly as you think it will. I might make another video about ordered listeners at another point, just to kind of show all the difficulties with this. There are some places in the game where this kind of matters. Okay, so ordered listener, let's get rid of that. So that just means it takes in a number of panels and determines if they were solved in a given order. The reversing listener is like the merging listener, except that it emits a untrigger signal when it's triggered and a trigger signal when it's untriggered. So it's a NOT gate is what it is. The SFX listener will send it's going to connect itself to the SFX player, and it's going to bind effect and effect unsolved. So whatever I put here is what it's going to bind as the effect to send to the SFX player. That's not very helpful. So let's look at SFX play in the SFX player global. So this is going to do its little stop. It's going to show its map type. And it's going to go, so type is what we're looking for. So let's go into the map of type. Here we go. So if I put in success, it's going to load this noise, unsuccess, load this noise, success low, unsuccess low, and pickup. These are the 4 noises that you have, 5 noises that you have. And so you can reference them with these strings. Once it does that, it's just going to play that sound effect. So the SFX listener, when it is triggered, is going to play a sound effect. When it's untriggered, it's going to play another sound effect. Song setter listener. You will be very shocked to learn that this decides to play a song. I don't know why the song name is different from the song path, so let's read over this. If it is not the case that the musicplayer.map has song name, then musicplayer.map song name is equal to song path. I see. So what it's doing here is I could just have opening words here. I could do the song name. I don't need the path. However, if I have a song name that is not included in the base game, I can include my own song here, and then I would need to make unique it to pack it with a map. Make unique is going to be all the way down here. Make unique. And then that would automatically load my map into the game. So song setter listener, when it's triggered, it changes the song. Does it change the song? I do need to make sure it does that. Yeah, musicplayer.song is equal to song name, and the music player, music play. So it's going to change the song whenever it is triggered. What does it do on an untrigger? It sets it to whatever the song was before the song setter was triggered. Teleport listener. So this is going to teleport its parent to the specified place, teleport point and teleport rotate, whenever you trigger it. It's not exactly hard. Yep. So this is going to send you to given coordinates. You don't need to fill in target path because target path is going to. Oh no. You can set the target path. If you don't set it, it'll look for its parent. I read that wrong the first time because I read too fast. UnlockReaderListener. So let's look at what this is. You get a key and a value. So it's going to look at the unlocks. So it's going to look at your unlocks file, and if you have if the key that you put in is equal to the value you put in, it's going to trigger. So what this is used for example, is the the control center color panel. So that sets a variable in the data.save file to be a particular color, and that is named the color field. So if I have color lavender, it's going to open a lavender door because there's going to be an unlock reader listener in the map with a lavender door that has that whole thing in it. I always forget how you spell lavender for some reason. So that looks for something in the data file. Setter is going to be the exact opposite. It's going to set something in the data file. So yeah, I mean this is just it. If the key is not already equal to the value, set the value, and unlocks is also going to save that. Visibility listener. On solve, it either hides or it shows. So once this is triggered, it either hides or it shows what you've seen, and it does the opposite on the untrigger. So if I have this set to show, and I put this underneath, is this going to show its parent? I believe it shows its parent. Get parent.hide. There we go. So if I put this beneath, I don't know, a bird in the sky, and I have a panel that solves the bird, then that could make the bird appear. And I mean, that's basically it. It shows or hides stuff. It just makes it visible. It does not control its collision. It does not control whether or not it's, actually there, quote. Worldport listener. This teleports you to a different map. So you would put in your map name here, you'd put in the entry point, and you rotate, and then it would send you to that map. KeyHolderListener 2, because I noticed there was two key holders. Because there's a keyHolderListener here in the nodes, and there's also a keyHolderListener here in the listeners. They appear to be identical. They use the same script. Okay, I deleted something I didn't mean to there. Now let's look at my custom 2. So custom animation listener. This is just going to look at the parent. If the parent needs to be an animation player, and when this is triggered, it's going to play the animation. And otherwise it will pause the animation, not play it backwards, but pause it. So this is what I used for the rings in Icarus. So when you solve the two Myrtle panels, this custom animation listener is below an animation player that rotates the rings and moves them all around. And otherwise, when you unsolve those, it pauses them. It doesn't play it backwards. It doesn't set them back to normal. Doesn't teleport them back to the starting places. It just pauses it. So this might not be suitable for all of your needs. You might need to modify it slightly to make it play backwards or to go back to your original point. This is another one that I made, visibility on maploadListener. I should have made an unmaploadListener and then used the visibilityListener. Instead, I combined two things that shouldn't have been. Whatever. So, what this does is basically it's going to hide something. It's going to hide something, wait a couple of frames, and then after wait a couple of frames before it calls itself loaded, because panels are going to load in within the first couple of frames. So if it's loaded, it returns. It does nothing. But before this load goes through, it's going to let all of those panels do their things. So this is how I made that initial sign, welcome front, welcome spine, on the in Icarus. Is I simply had this script underneath it. And so it waits for any panels to solve themselves, because that's what these 2-frame buffer period is for. And after it's loaded, it just returns if you untrigger anything. So it's not going to do anything once the map has loaded. I really should have made this more general. I didn't realize there was already a visibility listener at the time I was making Icarus. I hadn't really fully explored the system yet. So this has been your brief overview of all the different listeners in Godot.